Okay, hi guys. So we'll be continuing on seeing more on nuclear stability belt. So now, as the number of positive charges on nucleus increases, the number of neutrons also increases to minimize positive repulsion. Positive charges on nucleus increases. Number of neutrons also increases to minimize positive repulsion. Okay, so we have this nucleus. Oops. Okay, so and in here we have some protons. So the number of neutrons also increases so as to fill the gap between protons, so as to minimize the positive charge repulsion. Okay, so this is a proton and this is neutron. Okay, so according to trend we can see that Z up to 20 is nuclei is stable with n by p ratio 1:1, and but as Z goes upwards to 20, we see that n by p ratio increases in stable nuclei. Okay, and as a result more number of nuclei or rather no more number of neutrons, not nuclei, are required to reduce repulsion between protons. Okay, and as a matter of fact that the highest n by p ratio which was found in a heavy nuclei or other in a stable heavy nuclei was found to be 1.52, and that is bismuth with atomic number 83 and weight 209. Okay, so with X with the atomic number 40 and mass atomic number 20 and mass 40, this was stable with n by p ratio as 1:1. Okay, and we also have another atom Y with atomic number 80 and mass 200 is also was found to be stable with n by p ratio as 120 upon 80. Okay, so we found that in the two cases When we compare them, then we can say that in the two cases, when proton increased or the number of proton increased by 60, number of neutrons increased by 100. This is small p. Okay, so now let's see what are magic numbers. Magic numbers are 2, 8, 20, 28, 50 and so on. So nucleides in which neutrons or other in which nucleons have magic numbers are stable in nature. Nucleides in which nucleons, which is the number of neutrons plus protons, have magic numbers are stable in nature. Okay, and coincidentally this is also the number of electrons which are in expected closing of various energy levels or various energy shells. Expected closing of various energy shells. Okay, now let us see even odd theory. So even odd theory is number of neutrons, protons and number of stable nuclei. Okay, so when n is even, p is even and number of stable nuclei is 165, which is maximum. When number of neutrons and protons are even in number. When number of neutrons is odd, p is number of protons is even, then we have number of stable nuclei numbers are in 55. And when n is even and p is odd, then the number of stable nuclei are 50 in number. And when n is odd and p is odd, then the number of stable nuclei are just 5 in number, which are minimum. Okay, so with this we come to the end of this lecture. In the next lecture we will be seeing more concepts on radioactivity, and then we'll be seeing isotopes, isobar, isotones and terms like that. So till then, good luck and goodbye.